Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Coumarin, 2H-chromin, 2-1, is a bicyclic lactone with a benzene ring fused to a pyranone ring. The carbonyl, lactone C is equal to O, is at C2 oxygen at O1 and there is AC3 is equal to C4 double bond. Moving on to the next step. Reaction with two equivalents of PHMGBr, Grignard reagent. The first equivalent of PHMGBr adds to the carbonyl C2 of the lactone in a 1,2 addition. This opens the lactone ring to give an alkoxide intermediate. However, since two equivalents are used, the second equivalent also adds. Actually, with a lactone and two equivalents of Grignard, the first addition opens the lactone to give a ketone intermediate. Hemiketal collapses to ketone after ring opening, and the second Grignard adds to that ketone. The net result, after H2O workup, is addition of two phenyl groups to C2 giving a diol, or after ring closure a tertiary alcohol at C2 with two phenyl groups. More precisely, coumarin reacts with 2PHMGBr, the lactone carbonyl undergoes double Grignard addition. After hydrolysis, H2O workup, the product A is 2,2-diphenylchromin, 2-ol, or equivalently the ring-opened diol that recyclases. The actual product A is 2,2-diphenyl 2H-chromin. More accurately, A is equal to 2,2-diphenylchromin with an O, i.e., the tertiary alcohol. The lactone C2 now bears two pH groups and an O, tertiary alcohol, with the ring oxygen still intact, giving 2,2-diphenylchromin, 2-ol, a hemiketal type structure that is a stable tertiary alcohol in the chromanol ring. Moving on to the next step. The tertiary alcohol at C2, bearing two pH groups, undergoes acid-catalyzed dehydration. Elimination of water from the tertiary alcohol gives a carbocation at C2 stabilized by two phenyl groups and the adjacent oxygen, oxocarbenium. Loss of a proton from C3 gives the alkene, forming the C3 is equal to C4 double bond. Wait, dehydration would form C2 is equal to C3 or C3 is equal to C4. Since C2 bears the O and C3 is adjacent, dehydration gives C2 is equal to C3 double bond, but that would place the double bond between C2 and C3 in the chromine ring. However, looking at option D, it shows 2,2-diphenyl substitution at C2, the oxygen carbon, with a double bond at C3 is equal to C4. This means the carbocation forms at C3 after loss of O from C2 as water, and then proton loss from C4 gives C3 is equal to C4 alkene, retaining both pH at C2. This gives 2,2-diphenyl 2H chromine with the endocyclic double bond between C3 and C4. And for the final step, option D shows the chromine ring system with both phenyl groups on C2, the carbon bearing the ring oxygen, and a double bond between C3 and C4, the endocyclic position, which is consistent with dehydration of the tertiary alcohol at C2 where the C of bond breaks. Carbocation at C2 is stabilized by oxygen lone pairs forming an oxocarbenium, then elimination gives C3 is equal to C4 alkene. This is 2,2-diphenyl 2H chromine. A and B show only one pH group at C2, inconsistent with two equivalents of PHMGBr adding to pH groups. C shows geminal pH groups at C3 rather than C2, which is not the product of addition to the lactone carbonyl at C2. Therefore, the correct answer is D. Therefore, the correct answer is option D.